So yeah, VGA, right?
Yeah. Or there's HDMI too here.
And the microphone is here, or you can grab this one. Depending on what you like.
Yeah, I think it's easier with this one.
Yeah.
Or I don't know. What with slides? That's fine.
Yeah. So we have 40 minutes and 5 people. So I don't know.
No. It will be till 7.
Till
it's
7.
okay with Jan, but we expect people not to use it full time. So in the end, like it was like when someone uses it full time, the deck goes on. Maybe someone won't show up, etc. Right? So it's no waiting for anyone. It's like for some reason.
So it's VGAs then, right? Okay. Okay, so you can start.
So I think we can start.
Okay, guys, so let's start
Perhaps.
our lightning talks. The format will be each speaker has up to 10 minutes, and then we exchange without a break, and we'll be here until 7, right? It's 6 now. I don't know what time it is. So yeah, let's give our welcome to Michael.
So, thank you. My talk is 7 Ansible tips and tricks in 7 minutes. So about me, my name is Michael, but I do not have time to present myself. You can see all the other talk about it. So, I guess that everybody knows what is Ansible. Please raise your hand if you do. Good, perfect. So, I said that it will be a lightning talk, so it's packed with action and all kind of stuff. And the first trick is the action module that you can use with a variable called Ansible Package Manager, which is a nice trick, but it's deprecated with Ansible 2.0. And the way it works is that you can use that to install something on Debian, on Fedora, on RHEL, because it's able to dynamically detect what kind of a package manager you want, using the setup and the fact, and create an action that depends on that variable, which means that you do not need to set specifically yum or DNF. So that's how I make a portable Ansible playbook. So tips number 2. When people are using Ansible on the command line, you see that you need to give the group for the addocs command, and you have the group all. And it turns out that that group, well, you can use it for other stuff. For example, for a group variable. So if you have a variable that needs to be set for every possible server, you can use that. So this one is not a good tips because it's documented. But you can also use that group to get the list of all hosts on your system, which is quite useful, for example, for monitoring. Let's say that you want to declare an Nagios server, you want to ping all the server. You can either get a second copy of the list, which is quite bad, because each time there is duplication, there is risk of error, or you can use that trick, which is just a loop, and when you add a new server, it gets added. When you remove a new server, it gets removed. So, quite easy. Tips number 4, it's also a tips with a variable. It's a nice one. So, you get your Nagios server, and you want to get the IP address of the remote system. How do you do that? Well, it turns out that you can use 2 stuff. The first one is a variable, well, an array called hostvar, where you give the name of the server, which can be the name given by the for loop from the previous tips. And then you can use a nifty stuff, which is Ansible_default_IPv4. So we get the default IPv4 for Ansible, which is kind of equivalent to the public IP address. And Ansible does that magically. If you get 2 IP, one of them will be the good one. And that prevents to do complicated stuff like I do with other tools. So the 5th tips is more complicated. I think that a lot of people here are using CentOS or RHEL, and you may have seen that CentOS was out 2 weeks after RHEL 7.2. And for RHEL 7.2, systemd got changed. And I wanted to use journald and the export feature, but it was only on 7.2 or Fedora or newer distribution and not on the old one. So in an ideal world, I should just say, okay, for RHEL a version superior to 7.2, let's use that. But you cannot do that with Ansible. You can only give IP address or this kind of stuff. And it turned out that using group by and a specific Jinja expression, you can just test for the major version, create a group, and then apply journal.d remote to that specific group. So you can filter on any kind of variable, create a group, and be done with it. And it's working. Now it's no longer a problem because all hosts are updated, but in the future, well, it will help. So tips number 6, that's my favorite, that Ansible by default works with SSH. That's fine, SSH is secure, everybody knows how to use it. But most people do not know that you can use for other stuff. So for example, you can use it with a chroot, you can use it with, what do I have? You can use it with Windows, and well, you can use it with Ghostfish. So you can connect to an ISO file, modify the ISO file and write it. You can use it over Salt Stack. So if you already have a Salt infrastructure, like I do have for the Gluster project, and if you want to just get rid of this, well, you can start to use Ansible over the bus. And because, well, it will not be a good lightning talk if you didn't speak about Docker, you can also use it to connect directly to a Docker container and modify the inside of the container, which is a complete violation of the immutable principle, but I do not care. And the last tip is, well, the last tip is not so impressive, but I didn't have time. It's basically that you are not forced to declare everything directly. You can add your own host. Like, I can decide to make a playbook that connects to a remote host that I will not manage, but I can still add the host and make sure that Ansible connect to it using delegate to and remote user. And I don't know if people can read from that, that you can use add host module. And that's it. If you have a question, well, it's a lightning talk, so wait for me outside. And if you want to contact me, still the same stuff, my email, my IRC, no Twitter, no Facebook, no LinkedIn. Thanks for listening.
Okay, thank you. That was very fast. Yeah, very lightning. Okay, next one is Jakub or Alexander if he showed up. Okay, then Tomáš. Then we may have to repeat this like 3 times, both of you guys. Yeah.
Okay, hello. My name is Tomáš Kukrál, and I work at the ICT department at Czech Technical University, and my lightning talk is called Fun with Kubernetes. How we get to the Kubernetes? We have the prehistoric era, which we are using bare metal machines and deploying virtual machines manually and this horrible stuff. Then we discovered that we need more virtual machines and deploy them faster. So we started to use OpenNebula. And then we decided that we don't love our virtual machines. We just want to throw them away and use a different one. And now we are playing with containers and Kubernetes. Our deployment is very smart. We have just 2 Kubernetes nodes and 1 master. And a few running apps. I think it's 2 or 3 apps currently. But the deployment is backed by the self-storage. And this self-storage is running on 7 servers, which means that we need 10 servers to run our small deployment of Kubernetes. Sorry. Yeah, that's the map of our network. You can see here that we have the 2 physical nodes. They are called I1 and I2, and the iMaster is virtual machine, and it's running the controlling components of Kubernetes. Every component of Kubernetes runs in a container, except the kubelet. Well, I will talk about it later. And we are using self-storage for persistent data. and the bird-routing daemon, it's running OSPF and distributing routes to other servers. But the image gets a little more complicated when we started to think about high availability and fault tolerance. You can see that there is I1 and I2, but there are so many links and so many switches, and the image is inverted. So everything which is yellow is red, and it means that we are missing it. It's not done this way. The most important thing we need in Kubernetes is persistent storage, because as one OpenShift developer called us, we are the crazy guys running MySQL databases in containers. And from my point of view, NFS and iSCSI really sucks because it's a center point of failure and a huge bottleneck. And if this server goes down, then your whole storage is down. So we are using Ceph, as I said before, and we are using a RBD plugin in Kubernetes. But it's not as easy as it may look, because developers run just one proxy. It's usually Nginx, the application, and database. But when I try to deploy it in Kubernetes, I have to put a kubeproxy behind these three containers. But in production, it has many problems, because the app container knows get static assets, and I need to move these static assets from app container to proxy container. There are some CSS files and stuff like this. So I need another share there, which is used empty-dir plugin, and I need this hook called exec command, which is used for copying the shared assets from app to proxy. There is a share there which is mounted in proxy as well as an app. So just one container with app get, I think, 5 containers in Kubernetes after deploying. And there are, because we are running databases in containers, we need to backup them sometimes. And we are using Bakula. And it makes even more difficult, because in every pod must be running Bakula file daemon. And this file daemon must be able to communicate with the Bakula master, and it make it even better, even worse. It used 2 connections in both ways. So I have one crazy dream that I would like to use backup in a stream way. It's the same way as we are using for streaming Docker logs or streaming Kubernetes logs, that I would like to use MySQL dump and put it somewhere in dev backup stream or something like this. And I don't want to care, because Bakula container has then it's necessary to configure it and to take care of the networking. And when I was preparing the presentation, I get I think a really crazy idea that I can use my favorite MySQL dump and put it into the standard output, which means that this MySQL dump will be saved in Kubernetes logs, and it's kind of backup, and I can recover it later. But I didn't try it. Maybe if you have tried, you can tell me whether it's worked or not. And we sometimes need monitor servers, because if it's not running, that And our current status of monitoring is not very good, because we are monitoring just physical servers, where they are good in a good condition, and we are monitoring only the Kubernetes status, because it's not very easy to go into the Kubernetes and monitor each pod and the container. We are using a rock-solid solution based on Nagios and Observium, but it's not as easy as I would like to the reconfigure is rock solid because you cannot move rock very fast. So our current solution is not able to make changes in monitoring in seconds because pods go down and up. So we are currently not monitoring the pods itself. Sorry. And another favorite thing is ATCD. If you have ever tried to run ATCD, that you know that's not very easy to monitor it. There is so many metrics, and it's not just up and down. And Nagios wants 3 statuses: okay, warning, and critical. And ATCD has so many statuses that I currently didn't write a whole script to monitor all the metrics. Sorry? It's all. Thank you for listening. If you have any questions and we have time, I can try to answer it now, or just catch me outside and we can talk about the Kubernetes later. Thank you.
Thank you, Tomáš. And next, I think it's Neependra. Do you have slides? Yes. You have slides, right? Okay. And Alexander, did you show up? Are you here? Okay. It should work. If you want some water.
Yeah. Sure. Is it coming?
Yeah, look, it's added as a new screen, so you move the browser.
Hey, good evening, everyone. So today morning I gave a deep dive workshop on the topic, comparing the different orchestration tool for containers. So this is the slide of the GitHub page which I have used for the workshop today. You can just go back and try if you want to dig more into. So running containers on a single machine is not something what they're meant for. So you need to run containers in a production where you have multiple machines working in a cluster, and then you should be able to deploy your containers in production with features like replication, rolling updates, and all those features, so which you need in a real cluster or production environment. So that's where containers are going to be deployed, or the real use cases will be there. So why we need them? Because first of all, we kind of get rid of all our kettles. We want to move to all the pets, so that if some application is very complex, you want to make sure that it becomes very easy, and you should be able to deploy them and very easily, rather than waiting for some complex operation to happen. We want zero downtime, we want auto scaling, and we want eventually reach to a place where we can have multiple cloud providers and we are managing all of that from one command line. So there are different tools already available which are kind of helping out to do the orchestration. Swarm, Kubernetes, Mesos, Diego, Apache Aurora, Amazon ECS, Azure Container Service. So they can all help you out to move your containers in a cluster environment. So just want to briefly go about that, what we needed to have those orchestration to be done. So basically, we need, first of all, multiple nodes to be part of cluster. So as we know that whenever you want to deploy a cluster, you definitely need multiple nodes. There would be, some of them would be a master, some of them would be the slaves or the or the minions, what you call them. So master can basically go and say, okay, now deploy some containers on some nodes and all that. We'll come to more detail in that. So you need some way to identify that in a cluster environment, which is master and which is slave. So you need some kind of mechanism to handle that. Like in Docker Swarm, you have a token. So with that token, you create the cluster. And in that cluster, once you create the cluster, then they become part of the cluster. So basically, in the same environment, you can have multiple Swarm cluster, but they will be identified with different token ID. In Kubernetes, you have master and slaves. Then we need a container engine to run on each one of the nodes, which is going to host your applications. So we have Docker Rocket. This is going to host your run your containers on that. On top of that, then you need a single source of truth about configuration and other details for the cluster. So it's like if you are saying that I want to run 5 replicas of my application, then there should be 5 of them. There should not be either 4, either 3 or less. So you need some kind of key value pair mechanism through which everybody can refer and say that okay, am I the right configuration what I want to be? So the key value pair helps you out with that and for other users also. So you have etcd console, those kind of tools which is being available for you to manage that single source of truth. Then when you try to move to the containers with multiple machines, you would want container from one machine to talk to the container on the other machine in the node. So for that, you need to have some kind of oval network or some kind of way to basically reach to one container to another point. So how do you do that? So it's like there are VXLAN, there are different networking plugins from Docker. Docker have a lib network, then you have Weave, Calio, there are different solutions which has been built through which you can solve that problem. Then you have a scheduler to schedule the containers on the node. So basically, you would like to have some kind of a scheduler which would define that how my container are going to deploy on a particular node. So for example, you can say that put this particular pod application on the node which has SSDs. So you need some kind of mechanism to identify that. So scheduler would help you out in figuring that out, that if you have put some kind of a constraint there, that should be able to handle that. Then once you have prepared your application, now containers are mortals. So container can come and go any point of time. So now let's say you're running container earlier on machine 1, container dies, and it comes back on machine 2. But your application should not be worrying, or the client which is accessing that particular application should not be worried about that. So there should be a service discovery mechanism through which a cluster should know that how I'm going to change my path, or basically the correct path to the correct container which came on different node. Then you need some kind of a proxy or HA proxy mechanism sitting on top of your cluster. So let's say you are a client, you just want to connect to one endpoint, and in the back end you might be running 5 containers, you might move to hundreds of them. So whatever would happen, client should not be aware of that. Client should be just accessing the one endpoint, and they should be able to do that. And once you have that, then you would also want to have some kind of shared storage. So for example, if your container moves from one machine to another machine, and if it's writing some data on the disk, then the same data should be available on the other machine. So that should be able to, there should be no interruption in the writing, as well as the data should be there, what you have been writing there. So what you have some kind of shared volume, like GlusterFS, Ceph, a Flocker. There are different plugins which will help you out to do this kind of shared volume mount on both the nodes in the cluster. And once container moves from one node to another node, the data is already there because of shared storage. Now these are kind of broad features what we need in the different scheduling or different orchestration mechanism what are already available. So now just quickly see what a difference between them in Kubernetes, Swarm, and Mesos. So we'll just go and quickly just look at them. So Swarm uses, first of all, multiple nodes is common thing. Swarm uses token ID to identify the cluster. Currently, it just has a Docker as an engine available to run the containers. Swarm has different key value pair plugins. So basically, you can say, I want to etcd console, Zookeeper, BoltDB, whatever you want to use. You can just do plug and play with that. That's available with Docker Swarm. There's a lib network which would give you different drivers, but it also supports different network plugins like Weave and Calico. So that's supported in Swarm. And for the scheduling part, you have a couple of filters and strategies what you can follow, like nodes. You can have some node filter. You can have some filters based on filter based on containers. Like I want to run this container only when my DB is running on this node, something like that. You can have the container in different strategies, like you can say, spread my containers across different machines, or you can say just pick the one node and fill it first and then move to someone else. You can do a random. For service discovery, there is, you can use something called interlock, which is there, which you have to have an extra one. Basically, Docker Swarm by default, as of I know, they don't provide by default a internal DNS server or service discovery mechanism, other than putting the details of the containers on the etc host file. But there's work in progress through which you can have internal DNS or the service discovery mechanism like interlock there. So yeah, sorry, the interlock can also work as a HA proxy. So HA proxy is you need to have an HA proxy if you want to do load balancing with Swarm. And there are plugins like GlusterFS, Rexray, Flocker, which you can use with Swarm. Sorry about that. Oh man. This is setting in this laptop. Yeah, sure. My username is Khare, Nkhare. I'll just write it down somewhere. Can you help me out, someone? I'm really sorry about this. I don't know. Backspace. I want to go back.
And we're running out of time, but did Alexander or Jakub show up, or we can give more time here? So I just want to know. No, then they didn't show up. So we'll give you 3 more minutes to fight with GNOME.
Yeah, not me. Okay, so for Kubernetes, quickly we'll just finish off. Kubernetes has master and slaves. It can support Docker right now, but Rocket work is in progress. It currently has kvalue pair as etcd. It can have Flannel, Open vSwitch, Weave, Calico as a plugin for the networking. And in the scheduler, you would have predicates and priorities to decide where you want to run your nodes, containers, as well as you can have some kind of, like in OpenShift, we have different kind of strategies like SSD strategies. So basically put this particular container on a machine which has SSDs, different zone and all that. Then you have inbuilt clustered DNS server, which is, so you can have an add-on in the Kubernetes, which can help you out with service discovery. And then HA proxy is built in with Kubernetes. You have different volume support with Kubernetes. And there's a presentation which you want to kind of go and look back. I want to go one more time. So this is an architecture for mesos. I'm just going to skip that for time being. So out of time. Okay, so you can just go and look at this up. So yeah, GitHub/NKHARE. I don't know. Yeah. Yeah. Okay. Thank you.
Okay, thanks everybody for listening and for participating. Please do rate the lightning talks, and we hope to see you here tomorrow. That's it for today.